Hello. In this video, I'm going to show you little pieces of how to do Lab 6. The first step is to download the starter files for Lab 6, make sure they got the proper date of 2019, and then pick one of the labs you want to create your virtual machine on. I suggest either 3 or 5. I'm going to do 4 just for fun. Okay. The second step is to open these 3 files in PCB Artist. Okay, so open PCB Artist. All right, the second step is to open those 3 files in PCB Artist. Okay, where did I put it? Desktop, demo, there they are. I'm going to open up these 3 files. Again, the starter file is where you're going to start. Okay, so make sure that you have the library downloaded. So if you go to libraries, you should have the 445L, the 345L library, as the library on the top so that it has highest precedence. Okay. If you want, you can make sure that that all the components are updated. That should not require updating because of the starter file. Update components. Okay. All right, so the next step is to take pieces of your lab and move them, copy and paste them into the other file. So I'm going to take, you can see I didn't use this one. Again, this is a copy. So I'm going to throw away the things I didn't need. I'm not going to use the regulator from my Lab 4. I'm not going to use that. Okay, there are my switches, there's my display. Okay, so this is, I want all of this stuff here. Okay, and I do a copy. And then I'm going to come over to the SCH and paste it in somewhere where it'll fit. Okay, so let's paste it right here. All right, so here I want to think about it. Yes, I want the ground connected. Yes, PD6 is PD6. PC6 and 7 and 5 and 4 are all the same. I want one 3.3, one PA3, one PA2, one PA5, one PA4. I got one base. I got one speaker PD. So this is going to create a single net out of both of those. And that's typically what you want to do. All right, so I'm going to move this around until it's in a pretty spot. There we go. Click. All right. The next step is to connect the 2 processes together. So you will see that I have 2 port A's, 2 port B's, etc. Okay, and so in order to combine them, let's do an easy one first. Here's port C. I use them for my switches, so I'm going to go over here and grab this port C. This is the debugger, and one way to connect the nets together is just to make a terminal here. I'll just make this net, make these 3 nets. Okay, so these are 3 nets. I am going to make this one called, change its name, change net to PC7. That's going to link the 2 PC7s together. Change type, change name, display name, change net, PC6, display, change net, oops, change net, PC5, change net, Change that. Where are you? Change that. Change that. Click on that. Click, change net. Gotta click it. There we go. PC4. All right. Okay, so these are the these are going to be my switches. So I'm going to go over to where the switches are. And you see this is PC5, that's PC5, and so they're connected together. So if I were to click on PC4, you would see both connections. All right, so now that I've done those 4 things, I can kill this booster pack port C. Okay, and it's still wired up properly. Okay, let's do PD. Okay, so again, this is PD from the booster pack. I need to find PD from the single chip. There it is, hidden under here. No, that's A. There's E. There it is, down there. All right, see? That's PD. Okay, so what I'm going to do is I'm going to connect up all the pins I want from the booster pack onto the single chip. There's PD6. Here's PD7. Here's PD0. You notice there are more pins on the processor because you have them all. So now I'm done with port D, and I can delete the booster pack port D. Okay? And all of these things are still connected. See, this is still PD0, that's still PD7, and that's still PD6. All right, let's find port A. Here's port A. One of the ways you can do it is get really close, zoom in, and again, I'm going to connect 7 to 7, 6 to 6, 5 to 5, 4 to 4, 3 to 3, 2 to 2, and I didn't use the other 2. Now that I've got all the port A connected, what I can do is I could take the booster pack port A and delete it. All right? All right, a couple more. Didn't use port B, but I did use port E. Let's find my port E. Okay, there's port F. Okay, I didn't use port F either. All right, where's my port E? Okay. Okay, so I'm going to find the chip port E. Okay, here it is. Right, that's the chip port E. And move it down near the booster pack port E. Oh, that's A. There we go. All right, there we go. Again, if I move it close, all right, see that? Now I'm going to connect the wires together. E 5 to 5, 4 to 4, 3 to 3, 2 wasn't connected, 1 to 1, 0 to 0, and now I can delete the booster pack port E. Delete. All right. Okay. All right. What else do we got? A to A. Okay. Did A. So now I can look and see in my components if I have any more booster packs. Okay. I got my U1, which is the microcontroller. I got my U2, which is the regulator, and my oh, that's a switch up. Okay, so I don't have any more. I've completely eliminated the booster pack. All right, so now let's work on power. If you go over to nets, you're going to see what I ended up with is 3 different nets which are 3.3 power, and that's not right. And so what I'm going to do is I'm going to change them all to the same net. So here I'm going to do I don't want 3 different power lines, I want 1. So I'm going to change them all to the same value, merge these 2 nets together. The same thing with my ESP power. I'm going to have a single regulator for the entire device, so I'm going to merge all those nets together. Okay. All right, so now what if I do, if I look at my power base, you're going to see there is a single, this is my 5 volts from my battery. I'm going to have a 5 volts after the switch into the regulator, and then my 3.3 volts goes to everywhere else, including my speaker. All right, let's change the regulator because this is an ESP and it needs more power. So what I'm going to do is I'm going to swap this regulator out. So if I want to change something, I can change it, okay, from one regulator to another. And the one with the more power is the LM2019 3.3 volts. It's got the same pinouts, but it has more current. Okay, so I updated. What happened here? All right, let's try that again. Delete. Let's add it this way. Okay. All right, I'm going to add the LM. There we go. All right. Escape. Okay, just quit. Cancel. All right, so now I'm going to wire up this new regulator. Yeah. Wrong one. Escape. That one. Click. 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 I can get rid of this because that had to do with the other regulator. No, not this one here. All right, I'll leave it. All right, so now I have more current. I have up to 500 milliamps. All right. Okay. All right. So the next step would be to go to my nets and make sure all my nets are proper. You see that I would single one by one. I would go down and make sure I have a single ground. All the grounds are connected. I have a single for each of these. I want to make sure that they are properly wired, because if they're not done correctly here, they won't be done. It won't work. All right. Let's add some debugging features. Okay, we saw here. This is a test point, which is basically 2 holes in your board. You're going to solder a single wire on it, so that's not a physical component. But you can. These are nice because you can get an alligator clip on them. There's a test point over here on my circuit called PE3. If you want to change the name of it, I can call it PE3. Now I got a lot of unused pins, and so one thing I can do is wire it up to the logic analyzer. So I can tie PF0 up here to channel 0, PF1 up here to channel 1, PF2 to channel 2, PF3 channel 3, and let's add another type of test point, and this is a single hole test point. And escape. Okay. Cancel. Wire. All right. So this is going to be cost about 29 cents, but it's really awesome. I'll call it PF4, and it's just for debugging. It's got no other purpose for debugging. Okay? And so these pins don't do anything, but they can be routed into the logic analyzer. So you hook up to the logic analyzer any digital signal you wanna look at as a function of time. Okay. Now these are all weird nets. Notice I have some nets that aren't pretty named, and I got to change all of my nets to a good name. PF0, PF1. So there's no, to get a full credit on this lab, we want no nets to begin with this N stuff. Change net, PF2. Now if it wants to merge nets, think about it before you click yes, because that may be the right thing and it may be the wrong thing. Change net, PF3. All right, so now you can see all of my, oops, missed one, PF4. Now you can see all of my nets have pretty names. All right, save. All right, so save often because undo is your friend and stuff can get weird. Okay, so the next fun thing is, like I said, to make sure you have all the components are up to date, so there aren't any ones. And then we're going to do a forward design change. Okay, forward design change is going to map to SCH into the PCB. Okay, to bring them in line. You can look at this to see if that's what you wanted to have happen, but by and large, this is kind of what it looks like the first time through. A lot of things were changed. All right. So here's all my stuff. Again, I could do a forward. I could do a update components to make sure all my components are update. All right. Okay. So now the fun part is placing things onto the board. Let's start with some hard ones. Okay. This is my display, and I'm going to put the display on the other side of the board. So I'm going to flip it, and then I'm going to rotate it, and then I'm going to line it up right here. You can see I'm aligning the back two holes with the drill holes. Now the colors, this blue is silkscreen on the other side of the board. This cyan is sort of silkscreen on the top side of the board. Okay? And then I'm going to one by one, which side of the board are things at? This is my reset switch. I'm going to put it on the other side of the board as well. So I'm going to flip it and then place it. Okay? These are my switches. Let's start with up. Where's up? Up, up. I'm going to flip it and place it here. Again, they're going to be on the other side of the board from the processor. The switches are going to be on the same side of the board as the display. Up, down. Did I flip it? No. Flip. Flip. There we go. Let's see, right. Flip. Left. Flip. Left. Here's another switch. It's got a crappy name, so let's go back and give it a good name. Go over here to component, to switch 3. This is the mode switch, so let's call it mode. Mode. Nice to have things with the names that are forward design change, that names that mean something. Okay, there we go. All right. All right, so it should say mode on it now. It does. Flip it, flip it, flip it, flip. All right. I want to place things around so they fit. Okay. Where's my ESP? That's a weird one. My ESP, I'm going to put it not on the same side as the display, but on the same side as the processor. So I'm going to move it approximately here. I'm going to move my my drill holes into the center. This is my power connector, which has got to face outward. These are my drill. These are going to be my drill holes for the board. One more. All right. Let's see. Here's my logic analyzer. Let's put it over here. Now, if you rotate it, not that way, rotate it this way, it will then be a right angle facing out. So if you could put either a straight up or a double right angle and have it face towards the front of the box, so I can plug my logic analyzer into the side of my box. All right. The trick of this is to get everything on the board in a place that it's easy to route. Okay, so here's my power switch. Okay, so if you zoom in and look at the rat's nest, you can see that this guy's facing the wrong direction, so I'll rotate it. All right, you see the rat's nest is a short short stint. Here's my battery. It's going to go in here. Oh no, I got it backwards. It was the other way around. That's the battery. All right, there we go. That's 5 volts. Okay, that's my 5 volts. Okay. Here's my regulator. Again, you notice that the lines are crossed, so I'm going to rotate it. The other thing about this is this thing will bend that way. So from a three-dimensional standpoint, I could plug this in and bend it 90 degrees. I've got a couple of caps in here. Let's flip it around. Okay. All right, let's flip it around. There we go. Okay, let's flip it. Rotate. There's my caps associated with my regulator. This is my... and so for each of these components, I am going to try to wiggle it on the board in such a place such that the rat's nest is short. I can see the R10 is associated over here. I can see my capacitor. And now it is good to have your circuit memorized because where the capacitors are matters. So if you see here, C17 is the bypass capacitor for the LCD. C17, this one. And so I'm going to find C17 and move it near the move it here near the display. Okay. All right. And so for each of my devices, I got to figure out where stuff is going to go. Here's my speaker connection. So if I have an external speaker, I'm going to put it up here somewhere. Rotate. All right. That's where I'm going to connect my speaker up. And then one by one, I'm going to place things onto here so that my rat's nest, the yellow wires. Now, if you want to see the yellow wires updated, again, save as your friend. If you want to see your yellow wires updated, you can do a optimize nets, and it will redraw the yellow wires. Okay. So in summary, this first phase is to move the components onto the board to minimize the yellow, to minimize the yellow crossings and to minimize the distance of the yellows, and to also place the components where I physically want them. What side of the board they're on. In this particular case, I'm going to have the display, the reset switch, the power LED. Where's my power LED? I'm going to have it on the other side. Flip. So the power LED is going to be, yeah, that'll work, on the other side of the board. The board's going to be connected up to the box. All right, so each of the components is going to be placed on the board. Okay? All right. See you in a minute. All right. Some time has elapsed, and I have placed all of the components onto my PCB. The green line here represents the size of the board. And you can see I placed the drill holes in the corner. I've placed these switches on the back side of the board, which will be on the same side as the display. My reset is on the same side as the display. And everything else is going to be soldered onto this side of the board, okay, which will be away from the front panel. If you want to see the nets, you can always do an optimized nets, and that'll redraw the yellow lines. Now comes the fun part, and that is to connect all the dots together. All right, and so each of these yellow lines represents a trace that I have to do. And let me do some of the hard ones first. Okay, so I'm gonna put my mouse right here. I'm gonna scroll in. And then I'm going to look at these traces here, okay? PA2, PA3, PA4, PA5, and they're going to the display. And so I'm going to have to strategize a way to get all these signals over to display. So let's begin. Okay, so I'm going to click on the Add Track here. And then let's start with this one. Okay, I'm going to click here on the microcontroller, and it's going to be much easier to go from microcontroller to display and not from display to microcontroller. And that is because when I click on this pin here, it's going to force it to touch the microcontroller. Now this is too big a trace, so I'm going to type the S key, which is going to mean size, and I'm going to switch it over to 8 mil track, or signal minimum. Okay, and that's going to allow it to go. Okay, so I'm going to fit in here. Okay, and I'm going to go down this trace. Okay, so again, I want to remember where I'm going. Okay, where I'm supposed to end up. Okay, and that is, I'm supposed to end up there. And so when I go up, I'm going to change layers. That's an L. I'm going to be on the bottom. I'm going to go here, change layers again, and I'll be on the top. Okay, so in general, I'm going to go right to left on red and up and down on the bottom. Okay, so there's one. Now, if I had missed a track, it would have given me an error. Okay, let's do another one. This one here, you can see, is going to there, and so I can get right there. Okay, I'm going to, again, click here, type S, because it has to be smaller. And I'm going to drive it also through this track here. And now it's close enough that I'm not going to change colors. And again, that's a mistake. You see that? I made a mistake. So I'm going to do cancel and cancel again, escape. See, I wanted to go there. Okay, so escape. Let's try it again. I got to remember where I'm supposed to end up. All right, track, sample, size. Okay. Through here, and now I'm supposed to go into that one. There we go. Made it. Now, if you want to make it pretty, I can move this around, make that pretty. Okay. All right, so this one is going down there, so I'll do that. Trace. Okay. All right, so again, I'm going to make that pretty. I'll just move this down there, so it's like that. Okay. All right, a couple more. This one has to go up there. All right, that'll be fun. And so one way that I can do that is move this guy. Again, we're supposed to, I'm going to change the layer of that. I'm going to change the layer, L, and move it to the bottom. You see it adds the vias. That's going to allow me to get my trace by it. Okay. 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 Go out a little bit. Okay. And now I have to go up. So change layers. Change layers. Made it. All right. All right, that one, you see I didn't give myself a lot of space here. So I can do a couple of things. I can move this further over. Move this one further over. Oh, that's all right. Move this one further over. And then I can move that one further over. And now I have space. All right. Click. Okay, where am I going? Should have seen where I'm going right there. So, click, made it. All right. Now this one turned out to be ugly. What happened here? All right, go. All right. All right, you can spend hours making this pretty. Let me do a few more hard ones. You notice that the crystal is all done. Don't move it. This is a fairly easy one. Okay. going to put in a trace, change the layer, not the layer, sorry, change the size. All right. Now again, I might have put them on the bottom, but I'll move them if I have to. Size. And again, it's always good to know where you're trying to end up. Size. Size. All right. So that's basically how I'm going to do the traces. You can see it's mitered to go 45-degree angles. Let's do some power because power is a little different than traces. So the digital traces can be 8 mils, but anything that's going to have a lot of power is going to have to be bigger. Okay, so in particular, coming out of the connector here, what I'm going to do here is when I do this, you can see down here that this is the battery connection, okay? And I'm going to click it here, and now I'm going to change the size to make it even bigger, okay? So I'm now running at 20 mils. Now I couldn't put a 20 mil connector there because it would have it would have been too close to that. Okay, so then I'm going to click there to there. Again, this is a nominal power, so you can see it's going to be 20 mils. It's going up to here. That's connected to there. This is connected to there. This is connected to there. Those are all 20 mil powers. Okay, so that is my. This was my my 5-volt battery voltage there. Okay. All right. Let's do some grounds. Okay. Now I got to get ground under there, so I'm gonna have to go under it. Now I could just change this layer here. Click this one, change that one, change the layer, L, because that's my rule, and that is up and down. Okay, so click. All right, let's change the size. Size, yes, because it's because it has to fit under there. I'm going to make it a little smaller, and now when I click here, I'm going to make it bigger again. All right. And I don't want it too close to the via. Yeah, that's my ground. Here's my ground. Here's my ground. These are all grounded. This is all grounded. Now, this is grounded. Now, if you want, you can click ground there, and it shows me all the grounds. Okay, so here I got to connect that one up. This one. It's on the bottom. Let's see, what else do I got to connect? That's my ground. I got to connect these grounds. I got to get a ground down there. So I can go around this if you want. That's not horrible. I can go around. So let's do that. Again, there's not a lot of power that has to go here. I can get these by going down from here. Okay, so layer, put it on the bottom. Oh, already on the bottom. Okay, all right, already on the bottom. All right, there we go. So those three are connected. Again, you notice if you zoom in here, these red ones and that blue one don't cross. I mean, one is on one layer, one's on the other layer. All right. So now we got to get over there. Oh, here's a ground. I need to connect that one. So let's go here. All right. Yeah, that'll be easy. Connect the ground there. And now I can connect this guy to that guy. Let's put it on the top layer. Let's put it on the top because it's pretty much going right to left. All right, and let's put all these on the bottom layer, bottom, All right, click, 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 click. Okay, so you see I'm using big traces here for my power and ground, as big as I can make it. All right, let me do just a couple more power traces. Let's get the 3.3 volts connected. All right, that's this one. Again, I want a big size. I want to use the power nominal. Big. Oops, that's the wrong size. Okay, so escape. We'll try it again. I want the size. If I look down at the bottom, it can tell me, it says it's on the bottom and I want it on the top. So I'll go layer, put it on the top, go size, make it power nominal. There we go. All right, see, I'm detecting my 3 volts. Now I got to get this guy to that guy. Again, if I click this, it'll show me where all the 3 volts have to be. And so I want a great big power line into my processor. And so I'm going to go from here to there in a big blue, because I'm going up. I want it on the bottom layer. I'm going to go bottom layer like that. Okay, so I've connected. The processor is now powered with power and ground. Now I have a lot to do. So if I do a save, if I were to do a design rule check now, and I ask to check the nets, you're going to see there's going to be a lot of mistakes because I'm not done yet. Okay, these are all the nets that I have left to do, and that's my work to do. All right, so I'm going to shut off the recording and finish the nets, and I'll be back in a second. Here you go. I've routed all the traces. Now comes the fun part, and that is, does it actually work? And so again, I've clicked on what I think are all my nets, and I've made all my traces. And so the last step here is to do a design rule check with the nets. And so it's going to do the spacings, the line width, the drill size, the net completion, and we'll check, and we'll see how many mistakes I made. Yep, I got some mistakes. Now this is typical. I've got a track-to-track error. That means things are too close. And a track-to-via error. And I've forgotten a ground. I made 4 errors. Okay, so we're going to fix them one by one. Okay, so somehow I forgot a net. Okay, so there's a gap in my ground nets. Okay, so let's click on ground here and then see which one I forgot. Okay, okay, so these are grounds. Okay, this one here doesn't look like it's connected, right? So ground. All right, ground. Okay, so there's one of them. Okay, so I got to get ground into. Okay, so there's ground here. There's ground here. I got to get ground into these here. They don't look like. Okay, so here's a great big ground. I'm going to pass it up there. Okay. So let's go ahead and connect my ground up here. I want to go on the bottom side, trace. Okay, make sure I'm on the bottom. Not the size, but the level layer. I want them on the bottom. Okay. All right. There. Okay. To see if that worked, I can do another design rule check. All right, so let's see if that made it better or worse. Okay, try it again. There we go, 3. All right, so we got another ground. We got another miss. Net. Got another missing gap. Okay, so again, we got some more grounds not connected. Let's find them. ground. Okay, so this ground goes to there, goes to there, goes to there. Okay. Not connected. There we go. There we go. Right there. You see? That one right there, not connected. And that'll be an easy one because there they are right next to each other. All right, so connect this guy to there. Connected. All right, I could put them on the top. Let's go and put this up on the top. Control, 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 and change the layer. I'll put them on the top. Apply all to all segments. Yeah, there we go. All right. All right, that's that. All right, so now we can see the track to via right here. You see that? These two are too close. Fairly easy to fix. I'm going to grab my mover and move this one over here. All right, and move this one up there. Double click so it looks like that. All right, cancel. Okay, add a corner. All right, escape. All right, so I made those two farther apart. If you want to find them, you can go to errors. Okay, so let's look at my other one. Track to ground. Let's see this one. Where is it? All right. Track to track. Track to via. All right, that's the same error. All right, so again, I save it in case it goes really poorly, and do another design rule check. Okay, check. Oh, still got more packet. Gap error. Track to track on the okay. So gap is 0. It needs to be 7. Okay, that's really too close. All right, so let's find it. All right, so let's find it. Let's find where that error is. I just got too close somewhere. Where'd it go? There it is, right in there. Okay, so I got this too close. Oh, I got track. Oh, this guy's going right across. Look at that. I got 2 lines I didn't want to cross. Yeah, that was bad. Okay, so no problem. I'm going to have to kill a bunch of stuff to fix this error. All right, so I'll kill this guy here. Kill that one. All right, going to kill this one. And then I'm going to draw here to there. All right, let's fix that one. All right, yeah, what's this one? All right, click this one. That's PE0, PE0. Okay, so I'm going from here to there. If you want, I could have optimized nets, and there's my net that I have to fix. So you saw I had 2 bottom traces that I didn't want to connect. I had them crossed. That was not good. Okay, so let's click size to small. Okay, so now I'm on the top, right? So that's good. I can go on the top up to here, and then I'll go across this one here, and now I'll change layers. Okay, and go there. Ta-da! All right, that looks better. Let's try it again. Design rule check. Haha, no errors. Okay, so now I'm done with Lab 6. I printed it out and put it in a box. If I actually wanted to manufacture it, I would do a PCB configuration. I would make sure that it matches the configuration that we have for this class, which is 2-layer routes on the top and the bottom, silkscreen on the top and the bottom, green, LP1, color white. That's all our choices. It's an FR4. The minimum track width is 6 mils. The minimum hole size is 15 mils. These are all things that we are going to pay for you when we get to Lab 7. 1 ounce copper. That we put the student in here so it's cheaper. And then we put a board number here that represents the manufacturer number. So when we get the boards back, everybody's board has a unique number. All right, and we go finish. And so if you wanted to order it on your own, you could just order it. But we don't have to do that for Lab 6. All right, that's it. Enjoy this lab.